So what we're going to be talking about today is an introduction into the platform engineering and the context. Then we'll go a bit deeper into the internal developer portal concept. Then a bit more deep into concrete use cases, which we will demonstrate a few of using our platform. And we'll ultimately conclude with the impact of an IDP on the software development lifecycle, and then take some questions in the end. So without further ado, I'm gonna dive right in. So the context for platform engineering is that more and more digital products are created. A lot more applications are born each month, and public institutions as well are getting into the digitalization trend. So more and more code is being created by the day. And therefore more engineers are required to write this code. But unfortunately, not all of them actually, most of them don't have a good experience. And Gartner estimates that around 20% of the engineering workforce is constantly looking for a job at any given time. So that's 20% of the workforce, which is not really focused 100% on delivering value for users. And this happens because the delivery of software has become very complex. The development part has grown a lot into complexity, and the building and the releasing part of the application have as well been very complex, have become very complex in the last 10 to 12 years. And ultimately, this leads to a lot of time spent by engineers in troubleshooting the tool chain and figuring out what's wrong and reconfiguring things so they can do ultimately their job of creating and delivering software. So platform engineering is, we could say, a new discipline which aims to reduce the cognitive load for developers and therefore provide them with a better developer experience. This will help them to ultimately deliver more value for customers faster through the increase in developer productivity and through retaining talent within an organization. Well, how do you actually use the platform engineering concept? How do you consume it? First, it needs to be self-service for developers. You need to eliminate those waiting times and those dependencies on other teams, so the development teams can do their job whenever they need to. It will be used for both development and delivery of software, and it should abstract away the complexity of frequent tasks, of mundane tasks. And I'd like to get a bit deeper on this because abstracting does not mean hiding the complexity. It means hiding when needed, or to be more precise, not showing it when it's not the case. It means allowing developers to skim through the process whenever something goes well, but it needs to also have a layered approach in which developers can go deep if they need to. If they encounter issues while performing these tasks like deployments or builds, for example, or when they need to change something, they need to be able to go deep, understand what's happening behind the curtains, and be able to modify this behavior according to their needs. So I would like to pinpoint this abstraction that it's not completely hidden for developers. It needs to be very simple to use, right? And offer the layered approach. This is very important. Then Amin will go a bit deeper into this topic in a bit. Platform engineering ultimately provides a set of scripts and APIs to consume for teams in order to efficientize their work, to reuse what's already working. And this is also usually called the golden path of achieving something. These can be in a raw form, or they can be packaged into a developer portal, which is nothing more than a packaging of these scripts and APIs into a beautiful form for developers to consume via user interface. This user interface doesn't need to be graphical. It can also be a CLI tool, for example, but it's a high-level abstraction of what's underneath. Where does it all fit into the system? Well, it should definitely replace the traditional ticketing-based systems when you're waiting for third party or for another team or for another person to unblock your work, because this is really not efficient. And it should give back the focus on the developer experience and therefore unlock the productivity that we used to have in the past, where things were less complex. There's also good news, because before, and I mean like up until a couple of years ago, there wasn't much choice in having an IDP, an internal developer platform. You should have built it. And obviously only large organizations could afford to do this. But now, due to these increased complexities, products are starting to emerge and to solve parts of these issues. So you also have the option to buy an off-the-shelf solution, or to integrate an existing solution, or to have a midway in which you're taking a platform and building on top of that to customize your workflows to your needs. This for sure will get you into the build versus buy dilemma. I'm not going to get into this now, but there are a few aspects that you need to consider here, like the time to market. How core is this for your activity? You will need to consider how much influence or control you have over the roadmap, and how well does the direction of a tool aligns with your plans, especially if you're going to buy a solution. I've mentioned the developer experience, but I'd also like to clarify on that. So what does having a good developer experience actually mean? Well, it's about reducing the cognitive load and offering mental space for developers so they can focus on solving real user problems, instead of doing chores and focusing on the tool chain and on environments and on the infrastructure. So you need to get the developers' attention and, very important, mental space freed up to focus on delivering actual value for the product. This ultimately reduces frustration. We hope it eliminates it, but we don't live in a perfect world. So reducing it will do for now. And it should allow them to use much of their time where they have competencies. So remove the tasks in the areas where they don't have core competencies, like handling infrastructure, for example, and shift that time towards being productive. And also the self-service aspect is really crucial in having a good developer experience, not relying on others and taking control over what you need to do. Why does it matter? Well, because the bottom line will also be affected by the experience that the employees have. And Gartner did a pretty complex survey in 2021, in which they corroborated results on various metrics. You have them in the slide. They corroborated it with surveys for the employee satisfaction. And as it turns out, happier employees, more satisfied employees contribute to the customer experience directly, put in the effort, are more inclined to stay in the company, work more effectively, and therefore increase the productivity. Who's talking about this? Well, obviously, we're not the only ones. Top analysts are discussing it. Gartner is the last one to formalize, let's say, these trends, and they recognized last autumn the cloud development environments and the internal developer platform as emerging concepts. While McKinsey found out that the top quarter of the organizations in terms of development velocity outperformed the market by 4 to 5 times in terms of financial results. And this is quite impressive. Here's the hype cycle for the emerging technologies. You can see the internal developer platform and the cloud development environments. They expect it to mature in 2 to 5 years. So it's going to be interesting times. I'm going to hand it over to Amin now to move forward with the IDP part.
Thank you, Sorin, very much for that beautiful introduction into platform engineering. It's quite new and quite vast at the same time, which is in one way mind-baffling. I am, although having issue sharing my screen. If you can check the settings on your end, please, Sorin.
Yes, all good. Should be good now.
Perfect. Thank you very much. All right, so this is where we start delving into one layer of the multiple layers that make up platform engineering. And we're going to be talking about the internal developer platform. Now, what do we mean by an internal developer platform? We're going to go through that. We're going to see who's responsible for it. We're going to go through who uses this internal developer platform. Why is the concept of, present nowadays, and why does it take one complete layer in the platform engineering section? And then we'll move on to seeing more examples and delving a bit deeper into the ideas behind it. And we'll see the benefits at the end. So just to kick it off, I'd like to share with you guys that internal developer platforms, it's not a new idea. It's not a new concept. Huge enterprises have been using IDPs for quite a while now. But the only reason that it became something more available and more spoken about is the fact that it's an emerging requirement. And this emerging requirement was brought forward to us by the widened scope of vast tools and utilities that developers nowadays, DevOps teams, operations teams are using in order to complete their streamlining their pipelines from point A to point Z, making sure their pipelines are fast, they're efficient, they're to the point. There are no blockers in between. There's no blockers in between the teams, in between the work. etc., etc. And this usually starts off with one keyword, and that keyword is self-service. We need to make sure that these different teams that are operating together, because usually in a software development environment, you would have your development, you would have your staging, different branches will have different features, will have different branches, which will require different deployments, applications, and the back and forth. And as my colleague Sorin mentioned earlier, the ticketing system is basically someone using nowadays agile methodologies, depending on methoding on the ticketing systems, is basically you using waterfall tools to implement agile mentality, if you want to. So there was a gap over there that needed to be fixed, and that gap can only be fixed if these teams can act independent of the other teams, but still within the same scope and still within the standards that would ensure that the advanced points, the different points that this application or feature needs to advance through to reach its final deployment, they actually are enforced. They're standards that are being followed. And this is where the self-service layer came to leverage the tool set that your different teams and departments are using in order to be able for these developers not to depend on different operations teams or different DevOps teams to configure, deploy, and manage their application infrastructure, which is the one little hinge that every developer has. It's working here, it's not working there. I did this, they did that, someone else pushed a change. There's always something happening. It's a very dynamic ecosystem, if you want to. So everyone needs to have this self-service ability for them to be able to actually configure, deploy, manage their own environments, and micromanage their own team, and at the same time still be in sync with other teams. And this is where IDPs play a huge role. And basically by streamlining these DevOps processes and automating any operations, workflows, and orchestrations that are required here. And this would come at a very good cost. Now, naturally, if you don't have something that is layered, that is abstracted, which my colleague mentioned earlier as well, abstracting this complex infrastructure tasks that are usually repetitive in an application development lifecycle, you would usually have to have some kind of pipelines that take everything from point A to point B without the communications in between. And this self-service layer that is created, it naturally will reduce the operational load on the different teams, even on the bottlenecks in these different teams, which is usually the bottlenecks in development are the operations and the DevOps. This is where most of the bottlenecks come through, because everyone needs to go through here for the application, the product itself to reach management, to reach the consumer, to reach everyone else. It has to go through this little bottleneck in order to be available for the public or for internal use. And this is the main purpose of IDPs. It helps these developers to have self-service themselves, whether they want to integrate new configurations, orchestrations, RBAC, scalability, for reliability, for delivery, for their own productivity. If they come up with a certain idea and they want to test it, they don't want to stop everyone else from doing it. No, I can do it myself. I can just create a new let me call it environment. And in that one, I'm going to test this idea. If it works out, I can merge it directly and just keep on moving forward. No need to redo or scratch and start over from the start. Now, with all these points that I mentioned, all of them coming together, these will naturally end up in enforcing specific standards, which we will talk about in a minute. Now, I'd like to jump into the traits of what makes an IDP good. But before I do that, I'd like to mention one more small detail. You might be thinking, who owns or who maintains this IDP that I'm using in order for me to make sure that everything I have is up to date? And what if I have changes, because it's a dynamic environment that we're working in? So this is where the owners and the maintainers of the IDP are usually your ops and your DevOps teams. And what they do inside an IDP is not manual work. It's basically they pave the golden path for the developers in order to be able to self-service themselves. Now, what do I mean by pave the golden path, which my colleague also mentioned earlier? By paving the golden path, we're talking about templatizing the infrastructure, that complex infrastructure that you have, that your application needs to service the consumers and the end user, if you wish. By templatizing these different processes that you have, that might be automations, they might be orchestrations, they might be different configurations, they might be role-based access maybe. You can have different tool sets, or you might introduce a new tool set and you don't have to redo the whole work from an iteration. You take the template, you update it, you apply it. And we'll see an example of that in a few moments as well. Now, once you have this templatization of these different processes that are in place, you will naturally end up with less communications in between for the teams that you have, because now they are more independent, yet following that one path that the operations and the DevOps teams put in place. And this is what is enforcing these standards, that you have your base teams, which are composing the bottlenecks in the old methodology of working. Now, these teams are enforcing the standards. They use code for definitions. For example, they might use Terraform, they might use Helm, they might use different technologies that are out there that would fit their needs and the requirements that they have. And this will make it easier for them to templatize this environment, which means they, if there's any change, which we are not advocating here, but things happen and change happens, discovery, maintenance, understanding, documentation of this complex infrastructure is easy because it's code. Basically, anyone who's working in the field will understand code. It's simplified code, definitive, and it's composable, meaning you can take parts out, you can put parts in, it's extensible, you avoid configuration drifts, which is the one little bug that every DevOps or ops person knows is a feature. Avoiding the configuration drifts in these environments is really crucial, because one small change that's not documented or that's not templatized will eventually create more drifts along the road once we keep on going down that path. So what makes a good IDP is basically a true self-service, which we just mentioned, the different paths and the different organization and how the schema of it works, to use the code definition, to be able to be composable, as in I can take a component in, plug it in, plug it out whenever I need to. Efficiency, not to take too much time for things to spin up. I don't need to wait for someone to finish their build in order for me to be able to actually start mine. No, I can have parallel build times. I'm giving a very specific example here of that use case. Flexibility, which means basically your IDP can actually integrate into your CI/CD without anyone having to do any changes, especially if it's a developer. They won't know what to change, and the DevOps team is probably too busy for them to do these changes. And this is where the extensibility and the good experience for developer experience comes from. All of these different points put together will come together to make up this whole set. I know I've probably thrown a lot of words here so fast. Soreen, if you have anything to add to that, if not, I'm going to try to jump into Bunny Shell and show around the platform a little bit after I do this one. But if you want to add anything, please.
No, nothing to add. I mean, thank you. Go ahead.
Perfect. So the main goal behind an IDP is the ability to have an easy onboarding process, whether you're onboarding personnel or you're onboarding your software into an IDP, and gradual adoption, meaning that whether we're talking personnel or software here, again, you will need to be able for them to communicate together and be able to adapt to these different changes as they come. Primarily, we're talking about 4 steps, which are you need to be able to connect to your providers, whether we're talking Kubernetes or we're talking in legacy or we're talking Terraform. Let's concentrate on Kubernetes more, as it's the edge tech nowadays, and it's used mostly and it's easiest to implement IDPs on. So you would have to connect to your Kubernetes clusters, container registries, Git repositories, communications like Slack, Teams, whatever you use for communications. You have to define your environment. By environment, I mean what components make up this product or this feature or this specific component that we're working on, or subcomponent, or maybe subsystem, not even component. We're talking about a whole system that depends on an IDP. You define these using code, clear syntax that is self-explanatory, which means everyone can pitch in, do changes, understand what's happening or what has been changed on this specific definition. And the third would be to be able to deploy these different environments on demand automatically, have triggers triggered by your CI/CD, whichever state works better for you. And the last one is to automate this process. The whole process of actually being able to define, deploy. We're not talking about the connect unless you have to connect other clusters for different resources. Then we talk about all the other three and automating the process in a loop. This will allow you to adapt, to move forward, to be allow me to say fragile, to sway with the wind of technology, if you want to. So next up, I'm just gonna actually, yeah. So how do we at Bunny Shell implement this IDP mentality? And how would an IDP generally implement these different requirements of automation? And how will these improve the experience of your developers? How will this improve the efficiency and the productivity of your developers? There are several methodologies out there, one of them being the idea behind service catalog, which I will show in a minute, but I just want to go through this slide before I jump to the Bunny Shell platform. So here we're discussing the service catalog. The service catalog is basically you have a standardized set of templates that your developers will use to deploy their applications or test their applications or run their automations or QA or whichever. And from that point forward, this service catalog, once it's updated, it will update all the environments that have been created from it. Thus, you are preventing this configuration drift from happening from the beginning. So we're taking a preventive approach to things. Another way is to be able to have test environments on demand, meaning if I've done something, I'm done, I want to move forward to the next task, I need to be able to create this on-demand environment and create my configuration or maybe change specific configurations, test the application, the product, the feature, the system, whatever the product is, and move forward from there. If I want to merge, if I want to scratch, start over, do another test, be able to have this on-demand running track if you want to. Next up is preview environments, and this is where the more end users and your consumers would play a bigger role in this one, like your managerial teams, your code reviewers, your QA, your security teams. These are the environments that they will use to do their code reviews, do their security checks, do their automations, maybe share with the stakeholder or anything of the sort. And the last is the cloud development environments. Basically, the whole idea behind an IDP is to be able to move forward without having any hinges along the way, whether we're talking about dependencies or whether we're talking about internal dependencies to the software itself. And the only way to eliminate that is to make sure that my environment that I'm working on, that I'm testing on, that I'm doing my QA on is actually an exact replica of what I have in production. So I went over this and gave a little bit more examples. I'm going to jump into Bunny Shell really quick here. Yeah, there we go. So this is our platform, Bunny Shell. Naturally, I'm not going to go over the whole system, but I just want to show you around how these things usually work. So here you would have a set of projects. These different projects will contain different environments. So this is just a container if you wish. These are the different environments that I have. These environments are defined by code, which we will see in a minute. And in the background, we've connected to our Git repository. We've connected to our provider, Kubernetes provider, whether we're speaking on-prem or we're speaking any of the major providers available. And let's go ahead actually and take a look at, for example, what it would be like to be using an IDP inside your organization. First of all, you have this environment, you've set it up, a specific team is working on it. They have the components here, they have their logs, this is where self-service kicks in. I don't have to communicate with my ops or my DevOps to understand what's happening with a specific environment. Now, this environment is stopped, but usually you would have your logs over here. We'll check, I'll see if there's a running environment in a minute. Stopping, deploying, defining dependencies, checking what was the last deployed version of something specific, or what's exactly happening in the background, and understanding what is being run, what is not being run, or if I'm rebuilding, I'm not rebuilding. Again, logs available for that specific use case. And let's jump back to the environment. So I want to see if there's something running. Yes, there is. So if we take a look at this one, the environment is running. I have these three components, which are the backend, the database, and the front end. And here I have the deployment, for example. I have the logs. The developer does not need to wait for anyone to do anything. Your ops, if they're doing adjustments, they don't need to ask the developers to check for anything. They can simply go for the configuration. This is your code as definition. So this is what is defining that those three components that you have with the different features available, like interpolation to be able to communicate in between these different components, and a lot more, which I can't cover right now, but I'm just want to skim over these. Domain generation, URL generation, templates, and this is what we spoke about earlier as well, for you to be able to have your own templates and see, for example, this Express, React, PostgreSQL example. You have the perfect summary, the documentation is here, everything is clear. Anyone who wants to create this environment has a full README file for them to be able to know how will I exactly, what do I need to configure, what do I need to deploy, what am I deploying exactly, and I can just do it by the click of a button, which is create the environment, select my project, name it, and create. Another thing is we can check the repository directly, and once again, we are here looking at just code as definition, and this is where the templatization is happening. Other than that, for preview environments, for test environments, for example, we can simply go ahead and clone an environment in itself. This is what makes it available on demand, or if you're automating the process, you leverage CLI, APK, the extensibility tools that you would have in order to be able to generate them automatically. Or simply, if you're using Bunny Shell, you can go ahead and link it to your pull requests and actually generate your test or preview environments as ephemeral environments and deploy them, do my checks. When I'm done, delete it, and it will automatically delete if I merge or if I close the pull request. I don't know if I skipped on anything specific. Soreen, if you would like to add anything to this section here on Bunny Shell.
No, it's pretty specific, so I wouldn't go too specific in this overview.
Yeah.
If anybody's interested, obviously we can answer some questions. But the idea was for you to make a first impression of the capabilities of an IDP, in this case, related to Bunny Shell.
And with that said, Soreen, I hand you back the mic.
Sure. Thank you, Amin, for the demo. I'm going to share the presentation again. Just 1 second. So here it is. So let's say you have integrated or built, or maybe you have taken a hybrid approach towards an IDP. How do you measure if it's successful or not? Well, one approach would be to use a framework called Sarah. It is based on trying to quantify the satisfaction, the adoption rate, the retention rate, and the advocacy for the internal developer platform. Obviously, the adoption and retention are true objective metrics. You can find them out by dividing the number of developers who have at least tried the platform to the total number of developers for the adoption. For retention, you would define it as the number of developers who use it, and you'd have to define what use it means, like performing daily deployments or weekly deployments or creating services, or what you need to achieve with the IDP. While satisfaction and advocacy are not true objective metrics, and you could get through surveys conducted with the engineering team. Implementing it in full or partially is up to you, but it's always a good idea to measure how well you're doing. And this is not just a pure metric. These kind of evaluations usually yield other needs as well. So once the people start to use it, they will have feedback, they will want more, or they will want less for certain sections, and this will be reflected towards the feedback. It's very important to start small, and this is something that we haven't mentioned yet. It's very important to start as small as possible and actually solving a pain that you're currently having. So solving a real issue and solving it well is the best way to start, and then build up on that with other needs as well. Also, I'd like to mention the actual impact that it's having on the developers' lives. Having an internal developer portal will help you in eliminating the bottlenecks related to environments, in solving that when can I have a staging problem, and allowing the development to actually flow towards the release through all stages. It allows you to run manual testing unhindered. It allows you to run automated testing in parallel and have like instant results, as opposed to having a single environment on which all of your automated tests are running, and you could, I don't know, wait up to 1 day to have the results and have them in 10 or 20 minutes, or how long does it take for your test suite to run. And it allows your teams to move as fast as they can to truly make good use of their time. Another benefit is that you gain consistency, you gain reproducibility, and this is very important to not waste time on flukes for tests, or for erratic behavior that might be caused by configuration drift. And one of the most impactful, directly and indirectly, benefits of having platform engineering implemented is that developers are able to focus on what they do best, and to provide you with innovation, contributing to solving the user's problems, instead of having their mental space occupied by other things which are only support to that core action that they do. This ultimately translates into having higher productivity, delivering value faster for your users, in having a better morale, and in having better reliability of the platform as a whole. through the reproducibility part, through being able to run automated tests a lot more than just in the final stages, just before releasing, and through having an environment available for developers to develop in and to test their own changes in, and these environments to have production-like configurations. So basically, developers are able to test the whole flow, are able to test the integrations as well, and not just a tiny piece of their code and then just mocking that up to other components. So it allows them to test on real environments. With that being said, I'd like us to move forward to the last section of our webinar, which is the Q&A section. So if you have additional questions, you can post them here. If not, we will conclude this webinar. So, Amin, I'll hand it back over to you.
Thank you, Sorin. I'd say let's just wait for a couple of minutes to see if there are any questions out there, and if not, we can move forward and conclude the session.
So, first question, can you provide an example of how platform engineering has directly improved developer morale in a real-world project?
Sorin, you want to take over, or you want me to answer this one?
I have a Bunny Shell customer in mind.
I do too.
I can't disclose their name, but they're a team who has done previously, they have done deployments once a month. So this was their release cadence, and this was, as you can imagine, a very stressful time for them. Right now, after being able to leverage an IDP and create environments whenever they need to, they do several releases in production each week. So there's quite an increase there, and they're much less stressed about them because these changes are, on one hand, much smaller than releasing once a month, and the other hand, they're much safer because they have been well tested before, and they just know they work. As a side note, they're doing tens of deployments for development and staging environments each day. So they're truly leveraging these environments to create robust changes, and then also be able to deliver them faster for their users, and much stressful. So developers are basically much more happy about this. That's all. If you want to add something.
Actually, I also cannot disclose any of the names of the clients, but there's the case of the 1 month cadence to several the releases per week. There's also another case of developers actually not even communicating with their ops or DevOps, and whenever the DevOps were upgrading the templates that they built their environments on, the developers didn't even notice it, even though their environments were up to date and upgraded. So there are not just impacts from a high level or a release state. There are too many subtle changes that happen internally that developers used to actually complain about a lot, and after starting to use IDPs or Bunny Shell in this specific use case, they completely are oblivious to what's happening in the background, yet it's happening to the environments that they are working on as well. I just thought it's worth mentioning that as well. That it doesn't just come with the benefits on your cadence or on your frequency or on your productivity. It comes with little details, very subtle details that no one would actually complain about or be happy that they're gone unless they actually were facing these issues.
Okay, thank you, Amin, for the detailed answer. So we have one more. What are the biggest challenges when implementing platform engineering, and how can they be addressed? Do you want to take this on, Amin?
Sure. The biggest challenge when you're adapting into platform engineering is enforcing your standards. And to enforce standards, you usually have to put them in place and understand what your different teams and your different departments' requirements are. That requires a lot of communication in the beginning in order to be able to objectively have a dynamically or adapting in template in place first and then moving forward. The natural process for you to be able to do this is to actually go take things simple. Instead of taking your software from here and dumping it there the way we used to do it before, no, this is not the process anymore. Now I take this little component of my feature, I do what the changes that are required to it in order for me to be able to templatize it. I templatize it, I move forward. Then I bring in another one and I put these two templates together and I put these two different components together. So you don't have to look at platform engineering or internal developer platforms just as from the scope of I have this template, I can remove this from it. No, actually look at it from a different perspective where you can actually build this template from other templates. So you move forward, you adapt, then you move down the ladder, back up the ladder, back down the ladder to the needs that you have. I don't know if I answered the question pinpoint to the point that you had, but if you'd like to any more clarifications, please let us know. Sorry, if you'd love to add anything, always be free.
Yes, no, you highlighted a lot of nuances here. They're very good perspectives on what needs to be done. And the only thing I would add to this is the natural tendency of humans towards resisting to change. So this is a factor that also needs to be taken into account. So basically, the way you solve this is by showing people the benefit of the future state, because they have something that's already working today, and they don't want most of the people don't want to learn something new just for the sake of learning something new. They want to focus their efforts where they do matter. So basically, you have to convince them that investing their time and energy will allow them to do better in the future. And this is how you can reduce or eliminate this resistance to change. You show the gap between the current state and the future state.
If I might add something, just you
Sure,
reminded
please.
me of your Sorin, a very dear colleague of ours in the past told me about a way to tackle this specific problem. And it's funny, I just want to throw it in there. He told me when someone resists change, tell them that I'm changing this so I don't ask you to change it later.
Yeah, good perspective as well. Nice. I think we have time for one or maybe top two more questions. So next one, what are the key metrics to measure the developer productivity, and how does platform engineering improve these? So related to having the some measurements or these metrics in your sites. I think that two of the DORA metrics, DORA stands for DevOps Research and Assessment. It's basically a standard which was started by Google and then widely adopted. Two of these metrics are very good of showing whether or not platform engineering has had an impact on your team. And these two are the lead time for changes and the deployment frequency. The lead time for changes measures the time since first commit until a feature reaches production. And obviously a team moving faster and doing more releases will have a better lead time, so a lower lead time than teams who are doing releases once a month, for example. And the other metric, the deployment frequency, is just that, how many deployments are you doing per time unit, like how many deployments per week or how many deployments per month. So platform engineering should definitely improve these two metrics. Anything to add here? I mean,
again, I'm just gonna throw in a minor detail that I've noticed actually while working on a specific use case, is that the number of notifications you get as a solution architect or a DevOps engineer should actually be added to those metrics. The number of notifications about issues you get per day or per month should actually be added, because that's the only thing that can tell you that, hey, you're doing better. Means you're getting less complaints, means you're getting less notifications from specific departments or specific teams. So also monitor the communications and the dynamicity of your team to understand better. Is this improving or is this not improving? Are the developers happy or not happy? Project managers usually have a pain with this one.
Yes, very, very good addition. Thank you for that, Amin. Yeah, so I think we have time for one single more question. Let's see. So how do you balance standardization of tools and processes with the need for flexibility and innovation by development teams? So for this, it's very important to, first of all, know your requirements, know what you need to achieve, and then you need to figure out how you will achieve it. Identify your constraints, like the technologies you're using, the tools that you're already using, and try to leverage as much as you can from what you already have. So choose a platform that allows you to reuse as much as you already have, and then go about figuring out what needs to be abstracted and how deep it needs to be abstracted. To also provide that layer, that option for the developers to go in and change things or debug things when things don't work out. And in order for this to happen, they need to be able to, first of all, understand, to have visibility, to have transparency of what's being ran there, how is it being ran, what are the parameters. So you need to balance the abstraction. That's the dial or knob I would look at to see how much I can abstract and how much I can make transparent for the users. So trying to sum it up, identify what you already have, what are your constraints, and try to find a platform or build a platform which reuses most of what you already have, because this is where the value is added in stitching up the things, gluing the things that already work for your organizations instead of rebuilding stuff. And then try to create an abstraction that allows the developers to walk past it when things work out, but also dive in when things don't. That's all from me. If you want to add something, Amin.
I couldn't add anything to that, even if I wanted to. Yeah, perfectly covered.
Thank you, Amin, and thank you for the presentation today. It was very insightful. I hope you had some information to extract from this webinar, and I hope we started your interest towards platform engineering and the internal developer portal. If you have any kind of questions, please don't hesitate to reach out. You can find us on LinkedIn or on our website, Bunny Show. That was all from our side. Have a great evening ahead, and thank you for participating. Bye.
Good night, everyone.
Okay, so the broadcast was ended. I'm not sure how to put this live because there was an option to edit the file, like the beginning and the end. So